Ladies and gentlemen, please join me in welcoming to the podium Mr. Chris. Welcome.
Thank you. Hey guys, can you guys hear me okay? Good. I know I'm being filmed. I tend to walk around a little bit. I'll try and get behind the podium enough to stay on camera a bit. Thank you for having me. Thanks, Fidelity. It's great to be here. It's great to be part of this. Thank you, Ken. Ken and I met at a conference about a year ago down here, and he came up and jumped on me, and we wrestled to the ground, and I said, okay. I thought the program was really interesting, and I'm really glad to come have a chance to talk to you guys. I'll give you just a little bit of background about me. Dr. Wong did a nice job talking about me. I am a native New Yorker. You don't hear my New York accent that much. My wife says, sleepy, drunk, or angry. That's when you hear your accent. I'm like, all right, what? What about it? Yeah, I grew up in New York. I actually grew up in a kind of an academic environment. I'm an NYU brat. I'm a self-taught engineer. Who wants to guess the last time I took a full semester class in computer science? 7th grade. Not kidding. You know, it's a little harder to get by in this field and actually bootstrap yourself up like that these days. So I really commend that you guys are in a program like this. It's a great program. And again, I'm glad to be talking to you about it. But I did have a chance to teach myself a lot of different things growing up in New York. Now, tell me a little bit about you. I want to hear from the audience right now. So tell me about yourselves. Who am I talking to? Freshmen? No? Sophomores? No? So who are you? Come on, thank you.
Sophomore, Timmy.
Mm-hmm. Who else? Tell me a little about yourself. Yeah.
Senior, CSC.
Very good. Who else? Just a little bit. Art history? Awesome. Oh, okay. I was going to say. And this won't go over your head, I promise. AOL has certainly a reputation, and to start my slide deck, I'm going to make a point. So here's my point. I am not here to toot the AOL horn too loudly, right? I'm here to talk about technology and some interesting things in technology, not to cheerlead for AOL. But AOL is an interesting story. You might be familiar with that. It's a little old school. I did email before AOL, actually in graduate school. And it was all command line terminal, and people thought I was crazy. The company has changed quite a lot. And yes, we actually still do dial-up. We still have about 3 million customers who pay us every month for their dial-up service, and no, they're not just senile and don't know how to turn off their credit card. They are actually sort of like, over my dead body, I'm not letting go of this client and the way that this works, and I know it and I love it. And so we happily continue to provide them service, and that alone still generates $500 million a year in revenue for the company. It is now a very small piece of the revenue of the company. That was a $20 billion business a dozen years ago. It's a smaller business now for lots of good reasons. So AOL does a lot of other things, and I'll tell you, I thought that was going to be the quiz question. That would be a little harder. We're coming up to our 30th anniversary. We used to send all these CDs to everybody. I remember getting AOL on a floppy disk. Then there was this little merger that happened back in 2000. You might have heard about it. It's the biggest failed merger in the history of the world. With Time Warner, that was kind of the low road. That didn't play out too well, and Time Warner finally said, we don't really know how to run this business anymore. We're going to let you be a separate company. So in 2009, AOL spun out, completely separate company. It is no longer AOL Time Warner or any combination there, a separate building, separate management team. We got a new CEO guy named Tim Armstrong. I joined the company about a year after he took over. And AOL's changed. It is quite a different company. So we do and provide all kinds of services related to websites, online delivery of digital media, and we have a whole host of different media properties that we manage and maintain. So I imagine at least some of you read the Huffington Post, but there's a lot of other services, Moviefone and Gadget, TechCrunch. You guys use TechCrunch? I was out torturing them just the other day. And we still have a huge mail business. While Google Gmail is certainly a very, very hot property right now, they have about 60 million, 70 million people using Gmail right now. As active users, we have about 35 million still in AOL Mail, so it's still a very big enterprise for us. The advertising business is a huge part of what AOL has become. So we publish all of these different websites and properties, and this is just a small list of the properties. And we also do advertising for our own properties, so we make revenue against these sites, and we provide services out into the internet. And I won't go into the gory details of all of that business, although when I started at AOL, I ran the technology for the advertising division. And we do really fascinating things like dynamic exchanges. So if you want to put an ad up on this page, when you click on the link to that page, we will try and figure out every bit as much as we know about you. We will look at the content that we're going to try and serve to you, and we will take that information and jam it together and put it out to bids to see which kinds of businesses would like to advertise against you, against that page. And we run an exchange arbitrage. So anywhere from 5 to as many as 11 or 12 different bids will come in. Someone will win the bid. We will grab their ads and we will start to load them onto the page. And we do that in less than 100 milliseconds. And we do that about 10 billion times a day. So that's just the advertising business of AOL. Google works fairly similarly. Yes, their business is a little larger than ours, although right now, we just did an acquisition a couple months ago of a company called Adapt TV Video. And again, I'm not going to pitch the video side of our business, but online streaming video is a huge part of the internet. It's an exploding part, especially for advertising revenue. We have our own video property. It's called AOL On, and we provide video ad revenue against our own content, as well as the content across the internet, and we do advertising for that well. And with the acquisition of Adapt TV and combining that with the video advertising we already do, we do more video advertising than YouTube. And you will see that there was actually some press releases about just a week or two ago because the ComScore numbers came out, and we are now a bigger volume of video advertising than YouTube. So AOL is a very different business than the Dial Tones and Meg Ryan. We're proud of that. It's an incredible transformation. We are not done by any stretch of the imagination. There's still 800,000 or 900,000 roadblocks in front of us that we've got to get over. But it's an interesting effort to do a turnaround, and that's part of the reason I came and joined the company, because the opportunity to transform a business like this and the kind of legacy that it's had, and to create a really new and different kind of company, still being able to provide services for those core users who want it, and frankly still provide a ton of revenue to the business. But it's not even a third of our revenue anymore, is an exciting opportunity for me personally. But I want to talk to you about some other things. Let me talk to you just a little old school. That's what mail used to look like only 6 or 7 years ago. This is a new version of AOL's mail. These are digital stacks, so your mail comes in and automatically stacks up like this, and you can click on it and see inside and see relevant content. There's a really interesting dynamic platform that we use to build this. Anyway, all this new stuff that we're building running these. You might have seen something like this before. Imagine you got a few of these running around here. I have lots of funny pictures of like spaghetti cable behind the scenes of servers. For those of you less familiar, these are racks of equipment. A rack holds what's called 30 used units of equipment in them, which is literally how many sort of pizza slices of boxes you can put in. Typical rack holds 30. Often that translates to 8 or 10 pieces of equipment, depending on the size of the equipment. We run 5,000 racks of equipment across a couple of major data centers. We own several of them. This is not a picture of inside of our data center. I'm not allowed to actually show you a picture from inside of our data center. I can show you one from the outside. That is, in fact, an AOL owned and operated data center. It's a big facility in Dulles. It's near one of our major campuses there. We own a couple of these. I'm proud of the data center and the teams that we run, but I don't think the data center business in and of itself is something that's especially exceptional for AOL anymore. It used to be that our ability to run all these products and services like this was one of the great differentiators of AOL. It's much more of a commodity business, right? People go to the Amazon cloud, right, and want to push things out. But there's some interesting challenges about why you may or may not actually want to be managing your own data center. And regardless, the ability to consolidate your footprint and to be able to run more efficiently is an incredible challenge, not just for AOL, but a lot of different companies. So we're going to come back and talk about that a little bit more. So here's an example, and this is sort of back to the theme of my presentation. To get big, you got to go small. When I joined AOL, we had 16 or 17 different content management and publishing systems against our various web and internet properties. And that meant different technical stacks. Some of them are in Windows, some of them are on Linux, blah, 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 right? And so we pushed to develop a more common standard across the company. And so we run a ton of our properties and pages against this platform we call AMP. And we can see how it's doing. We can go in and look at metrics on any individual property, and we could see how ad revenue's going. And we have an auto site, or AOL Autos. We can see what people are looking at and where they're coming from. And AMP provides all of these kinds of services. It's great, right? We can actually see how the site is performing and seeing users on it and the profit. It's not a good day. I always think this is a good one to show. Against a particular page, but how many views we've had against that site on a particular day. By the way, a lot of variability. We do 200-300 million web pages a day on our properties. That doesn't include all the ad serving components, right? That's just the actual page development. They're mostly running on this AMP platform. And you'll see much more modern looking stuff than what we used to have. This is the movie phone site. This is a patch and a special promotion we did for a new Disney movie that's coming out. Women's Style, other things like this. And they all run on top of AMP. What's interesting, and you've probably heard of Engadget. I actually grabbed this one today because I thought it was kind of fun because the new iPad came out today, right? And turns out Apple decided to give Mavericks away, right? The new operating system for free. I get these sudden calls. Are people all downloading Mavericks on their machines? Well, not all of our back office software runs on Mavericks yet. It was just released today. So there's a lot of people, as we speak right now, almost nuking their computers by downloading an operating system that actually, you can't log into our network on it. So I'm sitting here like making notes. I'm like, yeah, I'll just throw up some of the new Apple stuff that's being promoted up on Engadget. So we're basically telling our own teams to go ahead and download, make our lives hell. Anyway, Engadget runs on AMP too. I'm going to come back to why that's sort of interesting in a minute. But what's interesting about AMP, and again, this is just examples of going small, and then we're going to get to sort of the meat and potatoes of my presentation. We run about 85, 90 different websites, Stylist and Engadget and this, that, right, against that platform. The actual core engineering team is 7 people, and the rest of the engineers all sort of build on top of it. And it's a pretty powerful platform. Again, I'm going to come back and talk about it more. But you remember, right? So, what we're trying to do is to get small in terms of the actual software stacks that we want to put out. But that's expensive, right? And there's a lot of legacy stuff in it. So we're trying to move to the cloud. And we're trying to use a lot of different technology solutions to get there. We have, in fact, virtualized thousands and thousands of machines. I'm going to show you some examples how we do that. And a year ago, we decommissioned over 9,000 servers out of that center and a couple of others. And this year, we're already up to 8,300 machines now. I still have 40,000 in various places, but the numbers keep coming down. I try not to add them back as much. I'm trying to add more VMs instead of physical. We run some awards for all this decommissioning of equipment. The Uptime Institute, the company that came in second for server decommissioning, decommissioned 900. So we were like 10x them. And so we now have a tech center that really does look like that. Did I just show you a picture of inside an AOL data center? I did. It's okay. There's nothing too revealing about that. It's commodity equipment. It really does look like that. We run our own virtual cloud on it. Why aren't we doing it on EC2? All right, class, why aren't I doing it on EC2? Take a guess. Come on, there's no wrong answers. Why am I not using EC2?
You have less control where it's physically located?
That is a fairly important correct answer, but not the entire correct answer. So some data, by law, I have to control directly myself, right? There's confidential customer information. We've got information about children who are parents of subscribers. A lot of things we have to be compliant to a lot of different laws. So there are examples of that. Yes. What else?
At your scale, it's probably easier for you to maintain everything yourself than to go to EC2 or some other provider.
There are examples where that is exactly true. We transform massive amounts of data. On our advertising side, we're generating many terabytes of data every day. We're collecting over 10 billion bits just on the ad serving side alone every day. So that's part of it. But you could do that in EC2. Another reason, think of one of the pictures I showed you. So when you get out in the field, I'm going to here's some advice from your Uncle Curtis. When you go work for a business and you want to learn about the language of that business, it's not about tech. What's the language of business? Money. Gold star. And so when you're operating a business, even if you're responsible for just a piece of software or a little piece of infrastructure or you're the CTO, it doesn't matter. With the exceptions of certain academic institutions and certain nonprofits, you're there to make money. And hopefully you want to do it in a way that you also make awesome things and give people a really good experience and great service, but you're there to make money. So AOL has sunk a lot of money into those data centers. Those data centers were built 14, 16 years ago. They are world class. They're the highest tier data center you can get. They can survive all kinds of things, including Hurricane Sandy. No problem. No problem. Amazon went down. We did not go down. I got to stop jinxing myself. But the fact is that those data centers are huge sunk cost. So I already have an enormous amount of infrastructure that I can host equipment on at almost no cost. Guess what? My internal cloud costs less than EC2 because I already paid for all this infrastructure. I didn't pay so long before I joined the company. I already paid for all that infrastructure. All right, so that's an important thing to think about as engineers. It's all very well to go out and do the new coolest thing, but is that the most cost-effective choice? Now, if EC2 puts out features and functions and integration and APIs that I have to do all this work to develop to meet that, and that we need that as a business, there are examples where I will let data out of the company. But I don't typically do that because it's cheaper. And that's unusual. That's not true for most companies. So we have an interesting situation there. So I'm not trying to strangle the company. I'm not saying you can't go use EC2. There's plenty of examples. And there's other providers. But I can actually host stuff for less. So an interesting change for us. ATC actually is a lights out facility. So we've got this whole section now where we don't actually have to have anybody in the room. It's energy certified. All of our private clouds go in there. Now we're starting to distribute them, and I'm going to talk about how we do more of that in a moment. Lots of changes in how we operate. A lot of legacy stuff that can't get on the cloud right now. Bunch of proprietary C code, monolithic, living in some very weird compiled places, and we can't deploy them anywhere but right there. And so we're doing a lot of re-engineering, but a lot of the new stuff is all cloud enabled. We want to be a much more agile in our model and how we migrate ourselves to that new future. A lot of it's already happened. 40% of my systems now can all take advantage of that. 2 years ago it was only 20%. It's going to take a while to get to the rest, but this is how we become a more lean and agile and competitive company. By the way, we can work in extremely modern technologies on extremely high scale stuff, and it's exciting for a lot of young engineers to come in and participate in that. So we can now provision servers in seconds, right? And we can add services and application images to those package deployments in seconds. And we can roll it out for global distribution around the world in 1 minute. So it is available within 20 milliseconds of any physical location on the earth through this service. It's pretty cool. We built with a lot of open source products and some glue. That's our acronym for proprietary stuff that we can't talk about. And it's a pretty standard architecture. There's nothing revolutionary there. I don't need to reinvent the wheel. There's a lot of smart people, Amazon certainly amongst them, who've done great work in doing cloud deployment. We can do lots of different operating systems, different virtualization layers, right? And we can run it on different types of data center infrastructures, right? This is very similar to EC2. There's a saying in technology, right? Great technology stands on the shoulders of giants, right? How many of you are building your own windowing system on an operating system? Raise hands. Why would you want to, right? Who's building their own memory management? Yeah, no, come on, talk, because I want to kick you in the butt, right? Now, it's like, don't do it, right? So you're trying to acknowledge and lever that there are really smart engineers who've done amazing work, and our job is to steal them blind, no, to learn, right, and to work on top of their ideas. That's how this all works. So we can do really interesting things, and this is literally one of the pages off our internal sites, and you can, I won't blind you, but where's it going to go? Is it network? Which OS do you want? Which disk layout? Is there a capacity thing? Blah, 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 blah. Where do you want it to go? Blah, blah, blah. Press go. 8 seconds later, you have servers up. And then we can track how those servers are performing. Right? So we have dashboards that talk about implementations of fairly recent, it's October, so it's fairly recent grab. So right now, 14,000 VMs running across our properties. And vCPUs is, should be about double that number. And average provision time of getting system up from scratch is 17 seconds. Not great, I want it faster than that, but sometimes that's because you have multiple systems turning out, et cetera. And we got, still quite a bit of capacity, and there's 263 different properties running on it. Now, those are not all forward-facing consumer websites. Probably of that number, it's probably a quarter of that number. The others are probably internal systems, test boxes, all kinds of things like that, right? But there is, and we can look and see how they're performing. Okay. So it's all great that we've got virtualization, right? We've got a publishing stack that's simplified. It doesn't require a lot of engineers. A lot of people utilize it. But I still got those expensive data centers. And there's still lots of places where I want to be able to actually condense and consolidate my physical infrastructure. And I need to be able to roll through a couple of ways. And we've got some interesting business ideas. So we've developed an entirely new technology suite to deliver capacity anywhere for both us and increasingly some partners. So people are now starting to license what we've built. It's an extremely dense computing model. Right, we can squeeze a lot of capacity. Remember we talked about racks and how many physical devices are sitting in a rack. This is a lot more dense, right? We can put our micro data center anywhere as long as there's power, and it doesn't use very much power. It can all be managed and maintained remotely. It can sit inside any kind of normal office building. You can actually plug it into a 220 circuit. And it can participate in all of our private cloud stuff, right? And we do some interesting calculations, right? We look at the total compute, the TCC, right? all the work that we can get done, and we roll up everything, power, the leasing, the data center, like all the costs to deliver functionality, right? Including the support team, right? We depreciate the facilities, servers, everything, and we get a number, and that's our baseline. And with this micro data center, we get about 5x that TCC baseline in less than 10% of the cost and physical footprint. So we're taking essentially almost 50 racks of traditional equipment and shrinking it down into basically one. And it's a very low operational cost. Now, there are certain additional costs like blades and other things that cost a little bit more than pizza boxes. But when you think about the size of the capacity, I'm not saying it's 1/50th of the cost, but I'm saying I can get almost 50 racks worth of equipment into one. So it's a real thing. That is one of our micro data centers. It's sitting outside. And a couple pictures of it. That's, door open. Unit slides apart in different ways. You can see some of the different components in and out of it. We even have one on wheels. You can roll it around, take it off. It's very heavy. The guys had to put blue lights under it. I don't know, whatever. They're having fun. So here's the question, though. Will it scale? I mean, it's all very well that you've condensed it down, but what are you going to do with it, right? So let's go back to Engadget. It was about a year ago that Apple launched the iPhone 5, and our tech site gets a lot of traffic when they do new announcements and launches, like they had one today, and there's a lot of people come to watch the live blogs and things like that. And we have tools that let you watch it, so you can see Mr. Cook up there, and he'll show you his slides, and then our reporters will come up and provide editorial, and the slides will flip by, and we get a lot of people. I'll show you some statistics in a minute who come and watch this. And we see traffic spikes like you won't believe. So as an example, this is normal traffic for Engadget about an hour before the event. So we're getting something like 1 million page requests, page element requests a minute, right? About 17,000 requests a second. Still a lot. There's some hints about where this is going to go and the way this graphic is laid out. Right? That red line is the average load of all of our properties that we serve up against our NetScaler devices, right? Which is the sort of final end of the routers out to the internet. And we do a lot of traffic against those. I mean, Engadget makes up a sizable portion. It's a popular site. So when we get things like the iPhone 5, we have to scale like unbelievable amounts. So we decided we were going to test our micro data center against the traffic of Engadget on the iPhone 5 launch. So we put half of our traffic and routed it into one of those units of the micro data centers, and the other half through the rest of our farms. And if there was any problem with the micro data center, yeah, we did some pre-testing to see if we thought we could do it. We would always have failover into the rest of our traditional cloud environments. So this thing sort of kicks off, and yeah, traffic went up a little bit. So we were getting 372,000 requests a second against the system, and the micro data center handled 50% of them. So that one box was doing, what, about 180, 190, somewhere in there, 1,000 requests a second. And it sustained. I mean, people come and they go and so on. So we had 800,000 simultaneous users, 1.6 million unique users against the site in about a 2-hour period. And we get spikes like this a lot, and these are sort of unique conditions. Well, let's put it rare conditions, where events like this can cause enormous, and most sites start to implode. In fact, not to name names, but there are other tech blogs and so on that typically melt down or stop responding. And that's a pretty classic problem for many of them during some of these really big events. Again, I'm just jinxing the heck out of myself, but so far we haven't had that problem. And so we get really interesting performance like this, right, out of that micro data center. So we've been quite excited. So yeah, that's cute, right? I mean, it's adorable. It's got the blue lights, and it can roll around, and I don't know, R2D2 voice, whatever. But uh-oh, what happened here, right? So you remember Hurricane Sandy? As we were routing all that traffic through there, Sandy came along, and these data centers are right over here on the East Coast, up in Virginia. We kept routing the traffic through, and yeah, it passed. It kept running. In fact, they featured our picture in Data Center Knowledge magazine, and they did a whole thing because it sat outside the whole time. It sat outside through Sandy. I mean, remember the other shot? There's grass and stuff. It's outside. And in case you're not sure, remember this? See that? Yeah, that's it. It's sitting outside, right there. Outside of. So, I'll tell you a story. I'm sure you've heard examples of this, but I've been to many presentations where sometimes they say, smoke and mirrors, right? Well, and I learned a lesson about this when I was not much older than some of you guys. It was about 20 years ago, and I was doing, it's a long story, but I got to do a presentation for a very famous CEO in a very big company who's still the CEO of this huge multi-billion-dollar company. He likes to sail yachts in San Francisco Harbor. And the night before my presentation, I've been working on this new set of tools that they've got. And they're going to launch this new computer called the network computer. And it was back in the real early infancy days of the internet. And it's kind of a deviceless system, right? The drives and storage and database, no hands, were not built into the server. It was all through the network. And so the night before, the guy I'm working with was my friend Hiro, and we were in Japan. The launch was in Japan. And Hiro says, come on, I got to see up on stage. Huge stage, 9,000 seat auditorium, huge launch. And Hiro shows me there's this area that's roped off on the stage, literally velvet ropes, and there's this thing. It's got the thing. Look, it's the network computer. It's one they're going to show tomorrow. He's like, oh, network computer. And we're like, well, it's all roped off. Big shows the next morning. And he leans it over. Now, I'm not naming any companies, am I? No. All right. He leans over. It's made of wood. The ports and stuff are all glued on the back. It's like, bump, 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 wood. We were making jokes about throwing it in the tub. It's wood. It would float, right? And the next day, later that evening, Larry, comes up to me while I'm setting up a demonstration for somebody and asks me all his questions about the presentation. And he says, can you make this thing work in the Power Browser? Now, Oracle, at that time, did I say Oracle? At that time, it's just between us. At that time, was launching a bunch of things, including their own web browser. And a lot of companies were making their own web browser back then. We've got a database built in ours. Okay. So here's the night before this big launch. I got this whole thing, and he just suddenly throws can you make this work? And that's not in the spec. That's not what we were supposed to be showing. And it's the night before, and I got everything running. And I'm like, so I have about 5,000 conversations in my head in about 2 seconds, trying to figure out what I'm going to say to Larry. And then I think back to that presentation earlier in the day when Hiro showed me the NC made of wood. And I said, Let's see, he doesn't seem to care. It's made of wood. So in that 2-second moment, which seemed like hours of me trying to process what I was going to say when he asked me if I could, I said, no, but I could fake it. And he said, good, do that. So it taught me an interesting lesson about, so I mocked it together and it looked just like it was loading in a browser. You would never know. And it didn't really matter. The product wasn't going anywhere, and it's fine. How many of you use the Oracle Power Browser? Nobody. Okay. So that's not the point. The point was that, sometimes you see this kind of stuff, and oh, by the way, the launch went great, and the head of like worldwide marketing for all of Oracle comes up to me after, oh, you're going to be like the biggest programmer. This was amazing, and the launch went great. And I was like, okay, and never heard from him again. I'm serious. Never. Okay. But the point I learned from that is, if you're going to put it up there, really put it up there. So this lives outside. This is clipped right out of MapQuest, looking at the geosites. We're testing real products. We're putting real things into production. We're trying to do really interesting experimental things. Getting big, getting small. Small is a relative term, right? Something that looks big, not always so big. And so just when you think about big data centers, sometimes they're a little smaller. So yeah, that's a real picture of Arnold Schwarzenegger. Come on, Conan fans? Come on, who's not a Conan fan, right? All right, talking in the back, right? So this is, from the second Conan and the Barbarian, Wilt Chamberlain and Andre the Giant. And, sometimes this is how we feel. And sometimes this is the problems that we're solving because, you think you're big and you're going to rule the world, but there's always bigger guys out there. Okay, that's my story. I'm sticking to it. Thank you. So I'm happy to take questions, diatribes, anything you want to talk about. Doesn't have to be about this. I do hire a few engineers. It's about 2,000 full-time engineers in AOL, plus another 400 or 500 contracting engineers who work for us.
So if you take 50 racks worth of hardware and condense it all down into one rack, it sounds like now you've got a whole bunch of empty space. What are you doing with all that?
Yeah, so it's not, like I said, the cost ratio is not quite that good. But we're gonna sell one of those data centers, and we might even sell the second one. And we already start to lease space, and
You could lease it out to Amazon and run EC2 on it or something.
That's right.
Yeah.
That's right. That's right. Yes.
So when you deploy one of these micro data centers, how do you pick locations that have the right amount of bandwidth?
It's a good question. So we've dropped a few in Europe. We've dropped a few in Asia. So here's an example. So I was talking a little bit about some of the advertising technology, right? The bidding technology. If you go to New York, and I was in New York on 9/11. The stock exchanges are all right there, and they have data centers that literally just ring downtown. And it's because they want to be the tiniest little hops away that they can from the actual trading, right? Those little millisecond, really microseconds in some cases, make a difference in terms of their ability to do bidding. It's a little bit crazy, but they do that. And the kinds of bidding that we do, Google and others do for ad exchanges is somewhat similar. And we're dealing with laws of physics in some cases where we have to have servers and equipment co-located in a vicinity, typically within 100 miles or less of a particular hub. So if you want to do ad bidding in Japan, right, or in China, you need to have equipment there. And there's other reasons. Chinese tend to want to have a little more control over their own data. You might have heard about that. Tell you some other interesting stories about the Chinese government. So we have to be able to drop equipment in. And sometimes we get deals where, occasionally sales gets out a little bit ahead of their skis, as we like to say. And we're like, you need what, when? And so we often have to deploy very quickly. So this is part of solving problems like that. It is not the most cost-effective solution to deploy equipment. But if you need to get space simple and quickly, you can go and drop it into one of the major providers. We're at what's called a tier 1 provider on the internet, which means we peer. We're one of the very few. There's only 9 companies in the world that peer with the other telco providers. Google doesn't. And so we can peer into the internet as long as it's our property and our stuff. We can drop in and we can get, like an OC12 plugged into this thing. It's crazy how much bandwidth you can put on it. So, other questions? Yeah.
So I know you said in like 2012, y'all had cut down, I think it was like
9,000.
9,000. Then this year you're up to like 8,300.
Yep.
Do you think, I guess, towards the future there will be like a faster way to cut more machines down and move more towards the cloud, or is it just too like, costly right now?
It's a good question. It's expensive. Look, at AOL, we do a lot of things in the engineering space where we try and develop careers for individuals who want to just be engineers. Right? We have tracks where you can become senior engineer and a principal engineer and a distinguished engineer and a technical fellow. You don't have to have anybody reporting. You're just smart and you're a great engineer. And then we have management tracks. And the reason I'm pointing this out is you don't have to go into management to like make more money, and you don't have to worry about management issues if you want to be an engineer. But everybody needs to understand the financials of what they're building. And so we have sunk investments into things where it is just too cost prohibitive for us to go fast like that. We have systems. I'm running equipment, and I will not get too explicit about it, that in some systems hasn't been turned off in 8 or 9 years. Right? I don't know if it's actually going to come back if I restart it. I'm not kidding. It's funny, but it's not that funny. I'm going to cry. No, so that's not the bulk of the systems. But we have a business that's, and this is a classic problem, and I will try not to get too much on the soapbox. But as a technical leader and as someone who's trying to help, when you talk about a CTO, it's really different if you're a CTO of a 10-person company versus like a 7,000-person company. But either way, you're trying to help a business make the best technical decisions that they can and lever technology to the best way that they can, which is not always the fastest solution. It's not always the sexy, cool new stuff. It is this balance of what can the company afford to invest in now, and what is the cost of change, right? And sometimes that transition is extremely arduous, expensive, and distracting from trying to build all these sexy, cool new businesses. So there's this constant push and pull of trying to balance those levels of investments across companies. So we still have technology that, my data center plan for the migration is a 5-year plan, and we're in year 2. And I hope I can keep it inside of 5. Yes?
What if your micro data center fails or it goes into the
So, I'm sorry, say it again?
So what if your data center get crashed or get affected by something physically?
So we have mirroring across key systems and almost everything. A couple of those creaky systems are not so happy running anywhere else but in that physical building. By the way, that's the smaller of the two that we own. But the fact is that system is rated as category 5 resistant. So yeah, I mean, I don't want to tempt fate by saying how resilient it is, but it's survived many storms and other things. I mean, if we have a nuclear accident, it might be something else. But we are increasingly building redundancy for key systems, in other places. I've got stuff mirrored out in California and other places too. Yeah.
Yeah, you have shown us great stats regarding the amount of traffic micro data center can handle. But I have a question regarding online advertisements.
Mm-hmm.
So they are in real time delivering forward the ad request to a ad exchange.
Yep.
You have to serve an ad within the window of 120 milliseconds.
About 100 milliseconds, yeah.
Have you tested the micro data center on?
No, I have not put the ad systems up against the micro data center. It is because the ad systems are less amenable to cloud deployments, because they use certain kinds of proprietary technology for the exchanges that I can deploy them against the micro data center, but the engineering effort to get them to work in that environment, it'll work. I know it'll work. The machines have a throughput that I think is not going to be CPU bound by the efficiency of the software. And so for me, I don't have a driving reason to move those ad systems on the exchanges to it yet. But our guys are talking about new contracts with China, and we're probably going to have to deploy it pretty soon. And so the answer is no, I haven't done it yet, but I probably will. Yeah.
How do you address change management on a global scale? Is it a problem?
Oh yeah, change management's a big problem. It really depends on the systems. And when you have the number of different teams and different technologies and different stacks, so I won't go into the gory details of how the entire technology organization operates, but I have dedicated operations teams to major lines of business and to major technical stacks, and they have lots. We have engineers that are just there to do code deployments, and they basically own the code once it passes out of QA. They actually do the deployment, and they are responsible for rolling it out and our ability to roll it back and so on and so forth, and version control. And you know, we don't have massive, robust change management processes on Stylist. We do on the ad systems. You know, we do on mail. You know, things that are generating hundreds and hundreds of millions of dollars of revenue and are extremely complex. Another presentation, when you guys invite me back, I'll take you through the ad systems. It's over 300 different subsystems to deliver advertising. It's crazy complex. There's a lot of change control there. And we have different tools and services and operational teams that all manage that. Yeah.
So one of the reasons I know data centers are really expensive is that they've got a lot of redundancy stuff.
Yep.
In, like dust filtering and power cleaning and all
Yep.
that kind of stuff. Given that you've shrunk that down so much,
Mm-hmm.
I'm going to guess that you've had to make compromises on that type of stuff to some extent.
Mm-hmm.
How reliable is one of those? Like, how long do you think that one outside the Dulles data center could run if you just stuck it out there and left it?
It's been running for 16 months now. It's been running continuously. It's a good question. I mean, that's something a truck could knock over, but a truck is not going to knock over my data center, right? So there are certain, like I would not just deploy there, like when we did our test. Like, oh yeah, no, I'm going to have the other half of traffic go over here, and I want to know within 1 second that I could fail over to it entirely if I need to. So there are different kinds of conditions where I would say, I'm not going to deploy it there, or I'm only going to deploy it if I have a couple and they're synced together or something like that. But yeah, so those are all variables about deployment that we have to think about very carefully. But the level of sophistication of some of this equipment, and it's not our equipment, it's mostly off the shelf. I mean, you can get machines now, they're up to 64 cores. I mean, some crazy stuff that you can do if you really write really optimal. Like if you're using like a really strong procedural language like Erlang or Scala or something. I have actually the former CTO of AOL has got a little startup company out in Seattle. He's doing just that, and the kinds of efficiency that he can get is insane. And so I can manage on a blade card this big, you know, software that 10 years ago took a rack. And the blade only costs about, you know, $200, maybe $300 if it's really one of the big multi-core blades. And so if it fails, like I know when it's going to fail over and it's 2 inches away. So there's different variables now in terms of like what I can afford to juggle in terms of what would cause failure in systems and and what kind of redundancy I would build in depending on the nature of the deployment. Other questions?
No more questions. Thank you.
Thanks, guys.